A 3DCS variation analysis model requires 4 basic input elements: part geometry, assembly sequence, tolerances, and measurements. Part geometry defines the different features that will be analyzed in the model. If the CAD geometry does not exist yet, points can be used to represent part features. The assembly sequence defines how the parts locate to one another and their order in the assembly. Within 3DCS, a move defines how one part locates to another. Moves must be added to the model to represent each of these steps in the build process. No part can be manufactured exactly as it was designed in nominal CAD. Variation in a part's geometry can affect the quality and function of the assembly. Tolerances define the variation from nominal geometry within specified limits. Through moves, the tolerances of individual parts stack up and lead to variation in the overall assembly. Measurements then track this assembly variation. Measurements quantify the range of variation of the desired output, for instance, gap, flush, or clearance between parts. Even if some of the input information is not available, the model can still be created. Preliminary inputs are assumed and their values can be updated later. This can be advantageous if the model is created early in the design process, as there will be the greatest freedom to make changes to improve the design.